Assalamu alaikum friends. Welcome back to Chemistry Unlocked. In the last video, we completed a major portion of the periodic table covering elements up to group 3 along with their properties, trends and reactions. Now it's time to move on to group 4, which marks an important shift in the behavior of elements. So, let's begin exploring group 4 elements and understand what makes them unique in the periodic table. Okay. Group 4 is also called carbon group. They have 4 electrons in their outer shell, as we discussed in our last lecture. That group decides the number of electrons in the outermost shell. Group decide करता है कि कितने electrons हैं हमारे पास outermost shell में. So they have 4 electrons in their outer shell. They are less reactive than groups 1 to 3. Okay. Why is this? This is because as we move across the periodic table from group 1 to group 4, the elements have more protons in the nucleus, so they hold on to their outer electrons more tightly. Group 1 elements have just one electron in their outer shell, which they easily lose to become stable. That's why they are highly reactive. Group 2 elements, on the other hand, have lose 2 electrons, still quite reactive. Group 3 elements lose 3 electrons, a bit harder but still reactive. But in group 4, elements have 4 electrons in the outer shell. It becomes difficult to either lose or gain electrons. Losing 4 electrons takes a lot of energy as well. So instead, group 4 elements often share electrons to form covalent bonds rather than reacting quickly. This makes them less reactive overall compared to group 1, 2 and 3. अच्छा जी, इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि ग्रुप 4 में हमारे पास नंबर ऑफ इलेक्ट्रॉन्स टू ईदर लूज या फिर गेन करने के लिए हमें बहुत ज़्यादा एनर्जी चाहिए होती है, क्योंकि नंबर ऑफ इलेक्ट्रॉन्स ज़्यादा हैं, तो इसलिए वो लेस रिएक्टिव होते हैं. ओके, द थर्ड पॉइंट इज कैन ईदर गेन, लूज और शेयर इलेक्ट्रॉन्स. Okay, to become stable, group 4 elements have to gain 4 electrons. So they can have 8 electrons in the outermost shell to become stable. Or they can lose 4 electrons as well to become stable. या तो वो gain कर लें 4 electrons या फिर वो lose कर लें 4 electrons. Okay, now show both metallic and non-metallic properties as you move down the group. ग्रुप 4 एलिमेंट्स में मेटेलिक प्रॉपर्टीज भी होती हैं, नॉन मेटेलिक प्रॉपर्टीज भी होती हैं, जैसे आप लोग मूव करते रहते हैं डाउन द ग्रुप. फॉर एन एग्जांपल, कार्बन इज अ नॉन मेटल. सिलिकॉन ऑन द अदर हैंड is a metalloid. What is a metalloid? It is an element that has properties of both metals and non-metals. मेटलॉइड वो होता है जिसके पास मेटल्स की भी प्रॉपर्टीज हो या एंड नॉन मेटल्स की भी प्रॉपर्टीज हो. नाउ लेट्स मूव ऑन टू द ऑक्सीडेशन स्टेट. फर्स्ट वन इज कार्बन. Carbon has 6 protons, so it means it has 6 electrons. Now let's check out its electronic configuration. Carbon has 2 electrons in the first shell, 4 electrons in the second shell, which is the outermost shell. Carbon के पास 6 electrons होते हैं total, तो 2 electrons first shell में होते हैं and 4 electrons second shell में होते हैं. It can either gain or lose 4 electrons to become stable. So it becomes stable with a charge of 4 plus or minus, because it can either lose or gain 4 electrons. Silicon has a proton number 14, so it has 2 electrons in the first shell, 8 electrons in the second shell, 4 remaining electrons in the third shell. Now silicon can also lose or gain 4 electrons, so it has a charge of 4 plus or 4 minus, because it can lose 4 electrons or gain 4 electrons. Okay, now let's move on to group 5, which is also called the nitrogen group. These elements usually these elements usually gain 3 electrons to form -3 ions. Okay, let's check out what this thing means. ये हमारे पास 3 electrons gain करते हैं to become stable and to form -3 ions charge. Okay. For example, nitrogen gains 3 electrons because it is in group 5. So it gains 3 electrons. How? It has a proton number of 7. So it means 2 electrons in the first shell, 5 electrons in the second shell. How can nitrogen become stable? ये stable कैसे हो सकती है? It can either lose 5 electrons or it can gain 3 electrons. Which thing is easier? Gaining 3 electrons is easier, na? So it gains 3 electrons. Gaining electrons is easier because there are less number of electrons to gain than lose. So it gains 3 electrons to become N3 minus with a charge of 3 minus. With stable full outer shell, it has an electronic configuration of 2 and 8. 2 electrons in the first shell, 8 electrons in the second shell. Now let's move on to phosphorus. It also gains 3 electrons. Proton number is 15. So electronic configuration is 2 electrons in the first shell, 8 electrons in the second shell, and now 5 electrons in the remaining third shell. So it can also lose 5 electrons or gain 3 electrons. Which thing is easier? Gaining 3 electrons is easier. So it gains 3 electrons. It gains 3 electrons to become phosphorus with a charge of 3 minus. With stable full outer shell, 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in the third shell, and now it becomes stable. Let's move ahead on to group 6, which is also called oxygen group. These elements usually gain 2 electrons to form -2 ions. To become stable, these elements gain 2 electrons. Now let's check it out with the oxidation state. Oxygen gains 2 electrons. Oxygen has a proton number of 8, so its electronic configuration is 2 electrons in the first shell, 6 electrons in the second shell, which is the outermost shell. So which thing is easier? Gaining 2 electrons is easier or losing 6 electrons? Gaining 2 electrons is easier. Gain करना ज़्यादा easier है इस situation में than losing electrons. So it gains 2 electrons to become oxygen with a 2 minus charge. With stable full outer shell, 2 electrons in the first shell, 8 electrons in the second shell. Now it is stable. Now let's move on to sulfur. Sulfur gains 2 electrons as well, as it is in group 6. It has a proton number of 16. So electronic configuration is 2 electrons in the first shell, 8 electrons in the second shell, and 6 remaining electrons in the third shell. Now which thing is easier? Either losing 6 electrons or gaining 2 electrons. Gaining 2 electrons is easier. So it gains 2 electrons to become sulfur with a 2 minus charge with stable full outer shell. 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in the third shell, which is the outermost shell. Now let's move on to the group 7 elements, which are called halogens. Halogens कहलाए जाते हैं हमारे पास ये. Always remember, they are non-metals. Group 7 elements are non-metals. Non-metals होते हैं group 7 के elements. Actually, second is they have 7 electrons in their outer shell, as we discussed in our last lecture, that group number decides the number of electrons in the outermost shell. So group 7 means 7 electrons in their outer shell. 7 electrons होते हैं इनके outer shell में. They all are diatomic. Each molecule consists of 2 atoms. Example: fluorine, chlorine, bromine, iodine, and acetylene. Why? Because halogen atoms are very reactive and they need one more electron to complete their outer shell. They have 7 valence electrons now. So 2 halogen atoms joined together by sharing one electron each, forming a covalent bond and become stable as a diatomic molecule. एक इम्पॉर्टेंट पॉइंट हमारे पास ये है कि ग्रुप 7 के तमाम एलिमेंट्स डायटॉमिक होते हैं, यानी ये दो एटम मिलकर एक मॉलिक्यूल बनाते हैं, जैसे क्लोरीन, ब्रोमीन, आयोडीन, ये फिर फ्लोरीन भी है। वजह यह है कि इनके आउटर शेल में 7 इलेक्ट्रॉन्स होते हैं और ये सिर्फ एक इलेक्ट्रॉन गेन करना चाहते हैं फुल होने के लिए, टू बिकम स्टेबल। तो टू हेलोजन एटम्स अपने एक एक इलेक्ट्रॉन शेयर कर लेते हैं और स्टेबल मॉलिक्यूल बन जाते हैं, जिसे हम क्लोरीन या ब्रोमीन कहते हैं। इसलिए आप कभी भी क्लोरीन को Cl नहीं देखेंगे, अकेला नहीं देखेंगे, हमेशा Cl2 ही होगा। Now they gain one electron to form negative charge. We will discuss this point when we move on to the oxidation state. State changes from gas to liquid to solid. We will discuss this point as well later in this lecture. Very reactive, especially with metals and hydrogen. They are very reactive with metals and hydrogen. Always remember this. Reactivity decreases down the group. As you can see, reactivity decreases down the group. As we move down the group, reactivity decreases. In group 1 or group 2, the reactivity was increasing down the group. In group 7, reactivity decreases down the group. Always remember this. It is because down the group 7, it is harder to gain an electron due to weaker attraction from the nucleus. As we move down the group, the outermost shell electrons move very far away from the nucleus. So there is weaker attraction from the nucleus. That is why it is harder to gain an electron. Gaining electron is harder. क्यों harder होती है भाई? इसलिए harder होती है क्योंकि number of जब हम लोग जैसे जैसे नीचे move करेंगे down the group, तो outermost shell nucleus से दूर होता जाएगा, तो उसकी weaker attraction हो जाएगी nucleus से और वो difficult हो जाएगा to gain an electron. Now let's move on to a question which is mostly asked in the papers. What is molecular mass of two molecules of chlorine? Always remember this. Chlorine exists as a diatomic molecule. Diatomic molecule ही exist करता है ये हमारे पास. Which means one molecule of chlorine is Cl2. Now, atomic mass of one chlorine atom is 35.5. So, molecular mass of one Cl2 molecule is 35.5 into 2. So, the answer comes out to be 71. But the question is about two molecules of chlorine. So, we simply multiply. 71 multiplied by 2 equals to 142. Is a molecular mass of two molecules of chlorine gas. As we move down the group, color of halogens becomes darker. Let me show you this. Now look at this. Group 7 elements. These are the states. As we saw one point earlier, that state changes from gas to liquid to solid. So state at RTP. RTP. अब RTP क्या होता है? RTP is room temperature. Okay. State at RTP is gas of fluorine, and of chlorine is gas as well. So bromine state at RTP is liquid, iodine state at RTP is solid, and astatines state at RTP is solid as well. Now let's check this point out. As we move down the group, color of halogens becomes darker. What does this mean? हम लोग जैसे जैसे मूव करेंगे डाउन द ग्रुप, कलर हेलोजेंस का डार्क हो जाता है. अच्छा भाई, इसका क्या मतलब हुआ? व्हाट डज दिस मीन? फ्लोरीन when it is gas, so its color is pale yellow. Chlorine when it is gas, its color is greenish yellow. Bromine when it is liquid, its color is reddish brown. Iodine when its color is solid, it is dark gray. Astatine when it is solid, its color is black. So you can see color is getting darker down the group. Now let's move on to its oxidation state. To become stable, fluorine gains 1 electron. Proton number is 9, so electronic configuration is 2 electrons in the first shell, 7 electrons in the second shell, which is the outermost shell. To become stable, what can fluorine do? It can either lose 7 electrons or gain 1 electron. Now what is easier? Gaining 1 electron is easier, so it gains 1 electron to become fluoride ion with stable full outer shell, 2 electrons in the first shell, 8 electrons in the second shell. Now chlorine gains 1 electron. Its proton number is 17. It has 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell, which is the outermost shell. So it can either lose 7 electrons or gain 1 electron. Now what is easier? Gaining 1 electron is easier. So it gains 1 electron to become chloride ion with stable full outer shell, 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in the third shell, which is the outermost shell. So it becomes stable. Now let's move on to group 8 elements, which are also called inert noble gases. What does this mean? This means that they do not react because they have complete outermost shell. They are in group 8 now, so they have 8 electrons in their outer shell. Always remember this. So they are stable. They do not react. Noble gases exist as single atoms, monoatomic, not molecules, because they already have a full outer shell of electrons, which makes them very stable and unreactive. Okay, now let's check out some examples. Helium, neon, argon. These are the examples. All are non-metallic. Okay, let me check the examples. Helium, neon, argon. They are chemically complete, so they stay as single atoms. These examples you can see, they stay as single atoms. They are chemically complete because they have complete outermost shell. They do not react. All are non-metallic and exist as colorless gases at RTP, room temperature. Non-metallic होती हैं और colorless gases होती हैं. Melting point, boiling point increases down the group. Always remember these trends. Now, uses of noble gases. First one is helium. It is used in hot air balloons, airships. Why? It is lighter than air and non-flammable. Now let's move on to neon. It is used in fancy lights. Why? Because it produces a bright or red-orange glow when electric current passes through it. Now argon is used in light bulbs. Why? Argon is used in light bulbs because to protect the filament because it does not react. Now krypton it is used in lasers, special lamps, because it gives a bright light when electricity passes through it. Now radon is used in radioactive, used in cancer treatment. It means it is used in radiotherapy because it is radioactive. Now let's move on to transition metals, transition elements. First point is they form colored compounds. Colored compounds बनाते हैं हमारे पास जितने भी transition elements होते हैं. अब हमारे पास example भी है. There is an example as well of copper sulfate. Copper 2 sulfate. Copper 2 sulfate is blue. So you can see it forms colored compounds. Transition elements form colored compounds. Okay, now they have variable oxidation state. For an example, iron 2 plus, iron 3 plus, you can see the oxidation state varies. It can be changed. It changes. Can you guys see 2 plus 3 plus? Then there's one more example of copper plus 1 or copper 2 plus. So the charge changes. Variable oxidation state changes. Oxidation state changes. They are used as a catalyst. Transition elements are used as a catalyst. Okay. For an example, iron is a transition element, so it is used in the Haber process. Nickel is also a transition element. It is used in hydrogenation of oils. Another key point is they have high melting point and high density. Now, radioactive isotopes or elements. Okay. Elements with proton number greater than 82 like uranium or polonium are naturally radioactive. हम लोग इनको पहचानेंगे कैसे भाई रेडियोएक्टिव एलिमेंट्स को? ये वो एलिमेंट्स होते हैं जिनका प्रोटॉन नंबर 82 से ग्रेटर हो. हमारे पास एग्जांपल भी है, यूरेनियम की है, पोलोनियम की है. These are naturally radioactive. Okay. When the neutron to proton ratio is 1.5 or higher, the nucleus becomes unstable and emits radiation to achieve stability. What does neutron to proton ratio mean? It is the number of neutrons divided by the number of protons. When we divide the number of neutrons by the number of protons, if the answer comes out to be greater than 1.5 or equals to 1.5, the nucleus becomes unstable and emits radiation to achieve stability because it is radioactive. For an example, uranium is a radioactive element हमारे पास. Okay, let's check the proton number. The proton number of uranium is 92. It is greater than 82. As we talked about this in our first point, it is greater than 82. So we completed the first point. Now let's check the second point. Neutron number of how do we calculate neutron number? We calculate the neutron number by subtracting the smaller number from the bigger number, which is written with the element in the periodic table. How do we calculate it? 238 minus 92, it comes out to be 146. Now let's check the neutron to proton ratio. We divide the number of neutrons by the number of protons. 146, which is the number of neutrons, divided by the number of protons, 92. So the answer comes out to be 1.59. So it is greater than 1.5. So it completes both of the points. So it is radioactive. Now let's move on to some of the uses. As we can see, uranium is a radioactive element. It is used as a fuel in nuclear power plants and in atomic bombs. Why is this used in nuclear power plants? It is used in nuclear reactors to produce electricity. And it is also used in nuclear weapons because it can undergo fission, releasing a huge amount of energy. Now let's move on to cobalt. Cobalt is used in radiotherapy to destroy cancer cells. It is also a radioactive isotope that gives off gamma rays. In hospitals, these rays are used in radiotherapy machines to kill cancer cells without surgery. Now let's move on to carbon. Carbon is used in carbon dating and to trace metabolic processes. Carbon is a radioactive isotope used in carbon dating to find the age of old fossils and ancient materials. It is also used as a tracer in the human body to study chemical and metabolic processes. Now we will be moving on to the formula making. The first one is formula in which numbers are not cancelled. Now let's move on to formula making. The first one is formula in which numbers are not cancelled out. Numbers cancel out नहीं होते हमारे पास. For an example, we have calcium chloride. Write the symbols. In step 1 we write the symbols of the elements or ions. Step 1 में हम लोग symbols लिखते हैं elements के या फिर ions के. For an example, calcium equals to Ca, chlorine equals to Cl. तो हमने इनके symbol लिख लिया. In step 2, we write their valencies. Now what is valencies? Valencies is a charge. So हमने charge लिख लिया. Chlorine has a charge of minus and calcium has a charge of 2 plus. Now we cross over the valency numbers and we ignore the signs. How do we ignore the signs? We ignore these signs. This plus and this minus, we ignore it. And we just cross over the valency number. 2 comes over here and this 1 comes over here. So it becomes CaCl2. Now the final formula comes out to be calcium chloride, CaCl2. Now let's move ahead on to more examples like sodium oxide. Sodium has a charge of plus. Oxygen has a charge of 2 minus. So we cross over the valencies. 2 comes over here, 1 comes over here. It becomes Na2O. We don't write 1, okay? Always remember this. We don't write 1. Now calcium phosphate. Calcium has a charge of 2 plus, phosphate has a charge of 3 minus. So we just cross over the valencies. So 3 comes over here with the calcium and 2 comes over here with the phosphate. We ignore the charges, always remember. So it is Ca3PO4 and 2 comes out of the bracket. Now aluminum sulfate. Al3 plus, aluminum has a charge of 3 plus and sulfate has a charge of 2 minus. Al2SO4 3. The charge of sulfate comes with the aluminum and the charge of aluminum comes with the sulfate. So we cross over the valencies. So it becomes Al2SO4 and 3 comes out of the bracket. Now let's move on to the second one, which is called formula, in which numbers are cancelled out. We just learned the formula in which numbers are not cancelled out. Now numbers are cancelled out, okay? First one is calcium oxide. For an example, calcium oxide. It has a charge of 2 plus. Calcium has a charge of 2 plus and oxygen has a charge of 2 minus. So the charges are equal. So we just cancel the number of charges. Calcium और oxygen के हम लोग charges cancel कर देते हैं. So it comes out to be CaO. Now magnesium carbonate. Magnesium has a charge of 2 plus. Carbonate has a charge of 2 minus. So we just cancel these two. And it comes out to be MgCO3. Now aluminum nitride. Al has a charge of 3 plus and nitride has a charge of 3 minus. So we just cancel these out. It comes out to be Aln. Now we will be moving on to the transition elements. The first one is the copper 1 oxide. Copper 1, we do not ignore this. This is the oxidation state, like the oxidation number. Copper has a charge of +1. Oxygen has a charge of 2 minus. Oxygen पे हमारे पास charge होता है 2 minus का, so the oxide has the charge of 2 minus. So we just cross over the valencies. 2 comes over here with the copper and this 1 comes over here with the oxygen. So it becomes Cu2O. Now copper 2 sulfate, we do not ignore this. Always remember this. In transition elements, we do not ignore this. Copper has a charge of 2 plus and sulfate has a charge of 2 minus. We just cross over the valence. Oh, sorry. It gets cancelled out. Look at this. 2 plus and 2 minus are equal. So we just cancel it out. It becomes CuSO4. Okay. Now a single atom with a negative charge is also called a simple anion. It ends in an "ide". Always remember this. These come from non-metal elements where they gain electrons. As you can see, these elements are non-metals. Now let's check the ion formed from these elements. This is the nitride. Name of ion is nitride because ide ide comes at the end. Okay, always remember this. Ide comes at the end. Ide हमारे पास ending में लगा देंगे तो हमारे पास name आ जाएगा of the ion formed. Now oxygen is the second element. O2 minus is the ion formed. What is the name? ऑक्सीजन की जगह हम लोग आइड लगा देंगे, मतलब ऑक्स की आगे हम लोग आइड लगा देंगे तो ऑक्साइड हो जाएगा. नाउ फॉस्फोरस आयन फॉर्म्ड इज P3 माइनस, आइड आ जाएगा एंडिंग में, so it becomes phosphide. It ends with ide. Always remember this. Now carbon C4 minus is the ion formed. Name of the ion is carbide. Ide आ गया वापस. Hydrogen H minus. Now the name of the ion comes out to be hydride. Now let's move on to the if an ion has one less oxygen than the 8 ion, its name ends in ite. Okay, what does this mean? Look at this 8 ion name. It is sulfate. The first one is sulfate. So S formula is SO4 2 minus. Now if one oxygen is removed, it becomes sulfide. Look at this ite ion name. It becomes sulfite. Just 8 gets removed with the ite. So 8 gets exchanged with the ite. Okay, it becomes SO3 2 minus. Now phosphate PO4 3 minus is the formula of phosphate. Now if one oxygen is removed, it becomes phosphite. ite आ जाता है हमारे पास 8 की जगह पे, so it becomes PO3 3 minus. Nitrate is the 8 ion name. NO3 minus is the formula. If one oxygen is removed, so 8 gets exchanged with the ite, nitrite. Now NO2 minus. Now carbonate is the next 8 ion name. What is the formula? CO3 2 minus. If one oxygen is removed, the 8 gets exchanged with ite, so it becomes carbide. CO2 2 minus, as you can see, oxygen becomes less. So if an ion has one less oxygen than the 8 ion, its name ends in ite. Always remember this, and remember this as well. Nitrate is NO3 minus. If one oxygen is removed, it becomes nitrite. As we discussed earlier, it becomes nitrite, NO2 minus. And if oxygen is removed, then it becomes nitride. Always remember these points. Okay, हमने जितना पढ़ लिया आज के लिए बहुत है. अब मैं आप लोगों से मिलूंगा नेक्स्ट लेक्चर में. तब तक के लिए दुआओं में खास याद रखिएगा. अल्लाह हाफिज.